Let's put these ideas into practice by defining a recursive list class. So recall from earlier in the course the closure property of data. Some method of combination has the closure property if the result of combination can itself be combined using that same method. So, a tuple can contain another tuple as an element, therefore tuples have the closure property. And because of this, we learned that pairs are sufficient to represent sequences of arbitrary length. So a recursive list representation of a sequence 1, 2, 3, 4 was just to have a two-element tuple where 1 was the first element and the second element was the rest of the list, 2, 3, 4, which is represented as 2, and then the rest of that list, 3, 4, which is represented as 3, and then the rest of that list, 4. And then at the end, we had some empty list representation, such as none. So recursive lists are recursive. The rest of the list is a list. And we can now implement the same kind of behavior of nesting one thing inside of another using a class, because we understand how the object system works. So what's going to be different? In the old way, where we had an abstract data type just implemented with tuples and functions, we'd create this list 1, 2, 3, 4 by calling rlist over and over again, eventually ending in the empty list. And the new way is almost identical, except for notice that we'll use a capital R because this is going to be a class, whereas this was just a function. So this class rlist will take the first element of the list and then the rest of the list as its second argument. And the rest of the list is 2, and then the rest of the list is 3, and then the rest of this list is an R list which just contains 4. So when we have a one element R list, we just write that one element, and it's implied that the empty list is the rest of that list. Let's implement it. So here's the recursive list class. I declare a new class called rlist. I'm also going to have another class called the empty list. By nesting empty list inside rlist, I'm going to force everybody to refer to this class using this class. Meaning, it's just clear that this empty list is an empty version of this rlist. Okay, so we define this empty list, and we say that its length is 0 for all instances. And then we're going to create one empty list called empty, and we'll just use that over and over again, because we only need one empty list. Okay, now back to the R list. We're going to define its constructor to take the first element of the list and then the rest of the list, which by default will be empty. So if I don't provide anything for the rest of the list, I'll use this empty list that I created. I'll assert that the rest of the list is either an R list or the empty list that I created up here. And then I'll set the first and rest. Now I have to define the two properties of a sequence in Python. Namely, that I can get an item from an index and I can compute the length. So how do I get the item at a particular index? Well, if that index is 0, then I just return the first element of the R list. Otherwise, I'm going to reduce the index by 1 and look that up in the rest of the list. Return self.rest for index minus 1. Now what's going on here? Why is this going to work? Well, this is element selection syntax. And we just learned that what happens when Python evaluates an element selection expression, like this one, is that it looks up the special name getItem. So self.rest is an R list, and its getItem method is exactly what we see here. So by writing this expression, all that's going to happen is that we'll call this method that happens to have the special name that defines element selection in Python. How do we compute the length of this thing? Well, we'll take in an rlist instance, and to compute its length, we'll return 1 plus the length of the rest of the list. This too is a recursive call. So this is a recursive call, this is the recursive case, but where's the base case? Well, it's way up here. So the moral of the story is that methods can be recursive too. Let's take a look at this. So here's our rlist class, here's how we create one, here's how we compute the length, and here's how we use element selection. So element at index 1 is 2. And all of this already works. So we defined getItem and we defined len. And let's just load this in. And we'll see that S is an rlist object. And s.first is 1, and s.rest.first is 2, etc. Okay, the only thing that I don't like about this is that it's hard to see what's in the rlist all at once. But we can fix that too with Ripper. Okay, so how's this going to work? We're going to define a new function down here that is an expression for an rlist. So we're going to assume that S is a recursive list, and we're going to return an expression where it's a call to rlist, and the first thing is that we call it on the first element of the list, and then we call it on the rest of the list. So format, if you recall, is a method on a string that inserts whatever arguments I pass in here into these slots 0 and 1. So we pass in s.first and the rest. Now what is the rest? Well, it depends. If the rest is an empty list, we don't need anything here at all. Otherwise, I'm going to have to put a comma in and then follow it up with some expression that represents the rest of the list. So I can do that by just creating a string with one thing to fill in, which is the result of calling rlist expression on the rest of this list. So if I call rlist expression on S, which is 1, 2, 3, I should get rlist1, rlist2, rlist3. Now this is a string, which is why it has quotes around it. What we'd like to have happen is that this gets printed out every time I just evaluate S. And I do that with a special method name. Okay, so right now, all I see is rlist object. But if I reload Python, then every time I want to display what S is, it will call Ripper, which calls the rlist expression, which evaluates this recursive function, which gives me an expression that I can read and see the entire contents of this rlist.